Alright, for today's class, I want us to look at hydration of alkenes. We know that when an alkene reacts with water, we get an alcohol. For example, ethene reacts with water to form ethanol. So, in simple terms, hydration of alkenes is an acid-catalyzed reaction where water is added to an alkene to form an alcohol. We know that alkenes are unsaturated hydrocarbons. That means we can break the double bond to add an extra atom, right? So, hydration of alkenes proceeds in 3 steps. The first step is protonation of alkene to form carbocation. The second step is the nucleophilic attack of water. And the last step is deprotonation to form alcohol. Now, before we can go any further, I want us to define a few terms. The first term is protonation. Protonation is simply the addition of a proton or hydrogen ion to an atom or molecule. And as for deprotonation, that is the opposite of protonation. If protonation is the addition of a hydrogen ion, that means deprotonation is the removal of a hydrogen ion from a molecule. And as for a nucleophile and an electrophile, a nucleophile is simply an electron-rich species. And as for an electrophile, that is an electron deficient or electron poor species. And as for carbocation, carbocation is simply an electrophile. That means carbocation is electron poor or electron deficient. Now let's look into the reaction mechanism for hydration of alkenes. We say that the first step is protonation of alkene to form carbocation by electrophilic attack of hydronium ion, right? Remember that we say that hydration of alkenes is an acid catalyzed reaction. So in this reaction here, our acid catalyst is going to be hydronium ion, that is H3O+. But first, we need to show how we can form that hydronium ion. To form that H3O+, we are going to have H2O, that is water, abstracting a hydrogen ion. What happens next is that the double bond is going to act as a nucleophile. Remember that we said a nucleophile is a what? Is an electron-rich species, right? The double bond acts as a nucleophile, attacks or abstracts a proton. A proton, that is a hydrogen ion from a hydronium ion, forming a carbocation and water, right? Now, I want you to take note of those arrows. Those arrows are full-headed. And in the last video, we said that full-headed arrows shows the movement of an electron pair. And that arrow is moving from a nucleophile to an electrophile. The rule is that electrons will always move from a nucleophile to an electrophile. That is because a nucleophile is rich in electrons, but an electrophile is poor in electrons, right? The other thing that I want you to take note of is the hydrogen, right? The hydrogen attaches to the first carbon instead of the second carbon. The question is why? Let's look at the first carbon. The first carbon is attached to 2 methyl groups, and as for the second one, it is attached to 1 methyl group and an R group, right? So the hydrogen is going to attach to the carbon that is less substituted. In this case here, the first carbon. The first carbon is less substituted because it has 2 methyl groups compared to the second one, which has 1 methyl group and R group. Remember that an R group represents any alkyl group. That alkyl group can be propyl, can be butyl, can be pentyl, can be phenyl, and so forth, right? Hence why we are saying the second carbon is the most substituted, right? Now, moving on to the second step, that is the nucleophilic attack of water on carbocation, right? We say that carbocation is electron poor, that is electron deficient or an electrophile, right? So the carbocation is going to be attacked by a water molecule which acts as a nucleophile, right? And in the process, we have oxonium ion as our product, right? Now take note of the arrow. The arrow moves from the water molecule to the most substituted carbon, right? To show that electrons are moving from the nucleophile, which is the water molecule, to the carbocation, which is the electrophile, the electron poor or the electron deficient species. Now, the last step, which is deprotonation to form alcohol, what happens is that the water molecule is going to abstract or remove a proton, that is the hydrogen ion, from the oxonium ion, forming the alcohol product and regenerating the hydronium ion. That is the end of our class. Thank you.